There is no physical boundary marking the edge of the universe. No wall, no glowing frontier, and no final point where space suddenly ends. What astronomers call the observable universe is simply the region from which light has had enough time to reach us. That creates something extraordinary. When we look farther into space, we are also looking farther into the past. The James Webb Space Telescope has pushed that view deeper than earlier observatories, allowing scientists to investigate galaxies that existed when the universe was only a few 100 million years old. One remarkable example is MOM-Z14, a distant galaxy observed at an extremely high redshift. Its light comes from a period roughly 280 million years after the Big Bang. That number is difficult to imagine. Earth did not exist. Our Sun had not formed. The Milky Way had not yet developed into the galaxy we recognize today. And yet, somewhere in that young universe, a galaxy was already producing enough light to travel across more than 13 billion years of cosmic history before reaching Webb's instruments. At first, this sounds almost impossible. But the important question is not whether the galaxy exists. Observations have provided evidence that it does. The real question is how such a bright and chemically interesting system developed so early. As the universe expanded and cooled, gravity gradually pulled matter together. Gas collected in denser regions, eventually allowing the first stars to ignite. Those stars produced energy, transformed their surroundings, and helped create increasingly complex structures. According to earlier expectations, this development should have required considerable time. MOM-Z14 challenges scientists to understand just how efficiently those processes could operate in the young universe. Webb's advantage is not simply its ability to take impressive images. Its instruments can also analyze the light from distant objects. Spectroscopy allows astronomers to measure redshift and identify chemical fingerprints hidden within ancient radiation. For MOM-Z14, observations provided a redshift of approximately 14.44, placing the galaxy extremely early in cosmic history. That measurement is much more informative than a photograph alone. A faint red object might initially look like an ancient galaxy, but spectroscopy can reveal whether that interpretation is correct. It can also help scientists determine whether the light is dominated by stars, an active black hole, or another source. The chemistry of MOM-Z14 adds another layer to the investigation. Observations indicate an unusual abundance of nitrogen compared with what might be expected from such an early system. Nitrogen and other heavier elements require stellar processing, meaning stars had already begun transforming the simple material present in the young universe. This raises a fascinating possibility. Perhaps the first generations of stars formed extremely rapidly in dense environments. Some early stars may also have been much more massive than many stars found today. Massive stars live short but extraordinarily energetic lives, producing heavy elements and releasing enormous amounts of radiation. If such stars dominated early galaxies, they could have accelerated chemical enrichment. But scientists must remain cautious. One unusual galaxy does not rewrite the entire history of the universe. There may be several explanations for its brightness, chemistry, and compact structure. The significance of MOM-Z14 is therefore not that it has disproved cosmology. Its importance is that it gives researchers another extremely early laboratory in which to test their models. And the deeper Webb looks, the more important these tests become. MOM-Z14 may be only one galaxy, but its existence raises questions that reach all the way back toward the beginning of cosmic history. When its ancient light began traveling toward Earth, the universe was only a few 100 million years old. The cosmic environment was still undergoing enormous changes. The first stars were appearing. The first galaxies were growing. And radiation from these early objects was beginning to transform the surrounding hydrogen. This period is closely connected with cosmic reionization, when radiation from early stars and galaxies gradually changed the state of the intergalactic medium. That means galaxies like MOMZ-14 were not simply passive objects sitting inside the young universe. Their stars may have been actively influencing their surroundings. The unusual chemistry makes the story even more interesting. If nitrogen was already abundant at such an early time, scientists need to understand what produced it and how quickly the relevant stellar processes occurred. One possibility involves unusual populations of massive stars. Another involves complex stellar evolution. Other explanations may involve the detailed history of the galaxy itself. The important point is that researchers are still investigating these possibilities. The same caution applies to the galaxy's brightness. A distant galaxy can appear exceptionally luminous because of intense star formation, an active central black hole, or a combination of different processes. This is why spectroscopy is so valuable. An image tells astronomers where an object is and how it appears. A spectrum provides additional information about the physical processes producing its light. It can reveal redshift, chemical signatures, and clues about the energy sources operating inside the galaxy. That distinction is crucial when studying extremely distant objects. Webb is not simply finding ancient galaxies and declaring them impossible. It is providing increasingly detailed evidence that allows scientists to determine what these systems actually contain. And MOMZ-14 may become even more important if similar galaxies continue to appear in future observations. One object could be unusual. A large population would tell a much stronger story. If astronomers repeatedly discover bright, compact galaxies at similarly early times, they may need to adjust models describing how quickly stars and galaxies formed. That would not necessarily overturn the Big Bang framework. Instead, it could reveal that some processes during the universe's earliest stages were more efficient than previously assumed. Perhaps gas collapsed rapidly. Perhaps early galaxies experienced intense bursts of star formation. Perhaps massive stars were far more common. Perhaps black holes formed and grew surprisingly early. Or perhaps several of these mechanisms operated together. The evidence will determine which explanation survives. This is what makes the search so exciting. The observable frontier is not a literal edge of space. It is a limit created by the age of the universe, the travel time of light, and the sensitivity of our instruments. When technology improves, that observational frontier moves deeper into cosmic history. Webb has moved it dramatically. Instead of seeing only a vague darkness where the earliest galaxies were expected, astronomers are finding real objects, measuring their light, and studying their chemistry. MOMZ-14 represents one of the clearest reminders of how quickly the young universe could become active. But it is not the final chapter. There were stars before this galaxy. There were smaller structures before those stars. And eventually, there must have been the very first stars capable of producing the earliest light. Finding them is one of the great goals of modern astronomy. Every distant galaxy brings scientists another step closer. Perhaps future observations will reveal systems even earlier than MOMZ-14, helping researchers reconstruct the sequence from the first stars to the first galaxies. The universe did not become structured overnight. But it may have developed structure faster and more efficiently than earlier simplified models suggested. That is the real mystery Webb is helping us investigate. Not whether the universe has an edge, but how quickly the darkness of the early cosmos transformed into the enormous, complex universe we see today. And the deeper Webb looks, the closer humanity comes to finding the first light.